Good morning, everybody. Okay, we're going to do the last page of these conservation of energy simple machines worksheet. So, number 2 here, what we have that there's a 100-pound load, or I'm sorry, not 100-pound, 100 newtons. 100 newtons is the load. And we have these 2 types of pulleys, or 3. Now, first up, we have this one here. Now, if we look at this one here, how many strands are helping to hold up this box right here? And when you think strands, you can think hands. How many hands are splitting up the weight? Well, I only see 1 strand or hand splitting that weight up, which means it's 100 divided by 1, which means that you would still have to pull up with 100 newtons. Now, this person here would be able to use, their gravity, their weight to pull down, but they'd still have to use the full 100 newtons. All right, so now we look at this next one here. All right, this next one here. You could see that there's 2 strands. It's those 2 strands or hands are helping to hold up this pulley right here, which holds the weight. So we have 2 supporting strands holding that up. So 100 divided by 2 gives you 50 newtons throughout the entire rope. So that would be 50 newtons right there. All right, our third one. This one, people get confused because they see this here and this, it's connected to this person, but that does not count. The only strands or hands, 1 and 2, these 2 are holding it up. So again, 100 divided by 2 gets you 50 newtons. Okay, so you'll every now and then you'll have to look at it and kind of see, but I always like for you to think how many hands are helping to split that weight up. All right, next one, we got a 600 Newton block right there. All right, so let's see what we got here. How many strands or hands are holding this up? Well, this one is, that one, that's 2, 3, 4, 5, 6. Is this strand here helping to support the weight? It's not. It is not helping to split up the weight. So it does not count. So I only see 6 strands. So the answer is 6. What is the tension? Tension means force. It's just like all the other ones. So tension is force. Okay, so if we have a 600 Newton weight and we have 6 strands supporting it, then it's split up and 100 newtons of tension will be throughout the rope. Now with tension has to stay the same all the way through a rope. So it stays the same. So if this is 100, 100, 100, 100, 100, 100, 100, they add to 600 even though it's the same rope. Okay, but the strands we have is 100 newtons will be the tension there. All right, what is the tension held by the man? Again, the tension has to stay the same throughout, which means this dude here is going to have 100 newtons. Tension has to stay the same throughout the entire rope. If the man pulls his end down with 600 centimeters, how many centimeters will it rise? Okay, remember, you increase the distance to decrease the force, right? So we have that if we see 6 strands, that means the IMA, or mechanical advantage, is 6. So we have 6 is equal to the bigger distance divided by the smaller distance. The man is going to be pulling the bigger distance. He's going to have to pull more and more rope in order to lift up this weight. So we're going to erase that here, and we're going to say that you have 60 centimeters is what he is pulling down with, and the little distance, the smaller distance here is going to be how much it goes up. So we do a little algebra, right? I can do a little algebra, and I'm going to get that the D is 60 divided by 6, or 10 centimeters. 10 centimeters. All right, what's the IMA? I already said it. The ideal mechanical advantage of the pulley system is going to be the number of strands. With pulley systems, it's just the number of supporting strands, 6. If the man does 60 joules of work, what will the increase in potential energy be? Okay, the work you put in will transfer to the energy you gain. So if you have, and in this case, the energy is going to be P. Okay, so if you do 60 joules of work, you ended up gaining 60 joules of potential energy. All right, finally, we got number 4. Why don't balls bounce as high during the second bounce as they do in the first? It is, the answer is not gravity here. It is because every time the ball bounces, it's going to lose a little bit of energy. Okay? The ground and the ball are going to heat up after a while when you keep bouncing it, because that's energy loss, potential energy here, kinetic energy there. Those energies will get lost when it hits the ground to heat. Okay? All right. Thanks for watching.